Hello everyone. Today we discuss about the 7th session of Unit 1 of Heat Power Engineering. This session we discuss about the following contents, that is energy, heat, work and standard atmospheric conditions. Let us first we take as energy. Energy ಅಂದರೆ ಏನು? What is the meaning of energy? Energy is defined as capacity to do the work. A system possesses energy when it's capable of work. ಒಂದು ಕೆಲಸವನ್ನು ಮಾಡಲಿಕ್ಕೆ ಬೇಕಾದಂಥ ಸಾಮರ್ಥ್ಯವನ್ನು ನಾವು ಎನರ್ಜಿ ಅಥವಾ ಶಕ್ತಿ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಎನರ್ಜಿ ಅಪಿಯರ್ಸ್ ಇನ್ ಮೆನಿ ಫಾರ್ಮ್ಸ್. That is mechanical energy, thermal energy, chemical energy, electrical energy and nuclear energy, etc. Energy can be neither created nor be destroyed, but only changed from one form to another form. This principle is called as conservation of energy. Energy ನಾವು ಕ್ರಿಯೇಟ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ ಅಥವಾ ಡಿಸ್ಟ್ರಾಯ್ ಮಾಡೋಕ್ಕಾಗಲ್ಲ. ಆದರೆ ಒಂದು ಫಾರಮಿಂದ ಇನ್ನೊಂದು ಫಾರಮ್ಗೆ ಚೇಂಜ್ ಮಾಡ್ಬೋದು. ದಟ್ ಈಸ್ ಕನ್ವರ್ಜೇಷನ್ ಆಫ್ ಎನರ್ಜಿ. ಸೊ ಇದು ನಮಗೆ ಬೇರೆ ಬೇರೆ ಫಾರಮ್ಸಲ್ಲಿ ಸಿಕ್ಕುತ್ತೆ, ಕರೆಯುತ್ತೆ. ಎಕ್ಸಾಂಪಲ್ ಮೆಕ್ಯಾನಿಕಲ್ ಎನರ್ಜಿ, ಎಲೆಕ್ಟ್ರಿಕಲ್ ಎನರ್ಜಿ, thermal energy, chemical energy ಮತ್ತು ನ್ಯೂಕ್ಲಿಯರ್ ಎನರ್ಜಿ, ಇನ್ನಿತರ ಫಾರ್ಮ್ಗಳಲ್ಲೂ ಇದು ನಮಗೆ ವರ್ಣಿಸುತ್ತೆ. ದ ಯೂನಿಟ್ ಆಫ್ ಎನರ್ಜಿ ಇನ್ SI ಸಿಸ್ಟಮ್ ಈಸ್ ಜೌಲ್ ಆರ್ ಕಿಲೋ ಜೌಲ್. 1 joule means moving an object of weight 1 meter to a distance of 1 meter. ಯಾವುದೇ ಒಂದು ಆಬ್ಜೆಕ್ಟ್ 1 ನ್ಯೂಟನ್ ಇದ್ದು ಅದು 1 ಮೀಟರ್ ಚಲಿಸೋಕ್ಕೆ ಎಷ್ಟು ಎನರ್ಜಿಯನ್ನು ತಗೊಳ್ಳುತ್ತೆ ಅದನ್ನು ನಾವು 1 ಜೌಲ್ ಅಂತ ಹೇಳಬಹುದು. The energy can be classified as stored energy and transit energy. In stored energy, the energy available within the boundary, but in transit energy, the energy across the boundary. First one, stored energy. Stored energy is the energy of the system available within its boundary. A boundary ಒಳಗೆ ನಮಗೆ ಅದರ ಎನರ್ಜಿ ಪ್ರೋಸೆಸ್ ಆಗುತ್ತೆ. The storage energies are kinetic energy, potential energy and internal energy. First one, kinetic energy. The kinetic energy is the energy possessed by the body by virtue of its motion. ಏನು ಬಾಡಿ ಅಥವಾ ಮೂವ್ಮೆಂಟ್ ಇರುತ್ತೆ, ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ kinetic energy ಅಂತ ಹೇಳುತ್ತೆ. The unit of kinetic energy is Newton meter. So kinetic energy is equal to half mv square, where mv is mass of the body and v is velocity of the body. Next one is potential energy. Potential energy is the energy possessed by the body by virtue of its position. So potential energy ಯಾವಾಗಲೂ ಆ ಬಾಡಿ ಲೊಕೇಶನ್ ಅಥವಾ ಪೊಸಿಷನ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ ದ ಕಾಮನ್ ಟೈಪ್ ಆಫ್ ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಆರ್ ಗ್ರಾವಿಟೇಷನಲ್ ಎನರ್ಜಿ, ದ ಎಲೆಕ್ಟ್ರಿಕ್ potential energy and the electric potential energy. The unit of potential energy is Newton meter or joule. The Potential energy is equal to mgh, where m is mass of the body and g is acceleration due to gravity, that is 9.81 meter per second square. H is distance through which the body passes. Next one is internal energy. Internal energy is the energy possessed by the body due to its molecular arrangement and motion of the body. That is the structure of the body ಅಂತ ಹೇಳ್ಬೋದು. ಏನು ಸ್ಟ್ರಕ್ಚರ್ ಅಥವಾ ಬಾಡಿನಲ್ಲಿ ಮಾಲಿಕ್ಯುಲರ್ ಅರೇಂಜ್ಮೆಂಟ್ ಮತ್ತು ಮಾಲಿಕ್ಯುಲರ್ ಮೂವ್ಮೆಂಟ್, ಆ ಸ್ಟ್ರಕ್ಚರ್ ಏನಿರುತ್ತೆ ಬಾಡಿಗೆ ಅದರ ಮೇಲೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಡಿಪೆಂಡ್ ಆಗಿರುತ್ತೆ. ಸೊ internal energy is a microscopic in nature. A system's internal energy cannot be found. Only change in internal energy of a system can be found. The temperature is measured internal energy of the system and doing work on system. It is extensive property and point function. ನಮಗೆ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಗೊತ್ತಾಗಲ್ಲ, ಬಟ್ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ ಸಿಸ್ಟಮಲ್ಲಿ ಏನು ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ ಅದು ನಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ internal energy varies with the properties of system like pressure and temperature, etc. So change in internal energy is equal to heat supply and work done. So delta E is equal to delta Q plus W, that is mCV T2 minus T1 kilojoules, where m is mass of object and CV is specific heat of object and T2 minus T1 is the temperature difference of the object in kilojoules. Next one is transit energy. The transit energy is the energy of the body which is capable of crossing the boundary. Example, heat energy and work energy. The both heat and work energies are cross the boundary. So these two are cross the boundary. So it work and heat is crossing the boundary from the system and are enter into the system. So the heat and work is leaves the system, that is out of the system, it goes out of the system is positive heat and positive work is as considered. But when the work and heat is entering into the system, it taken as the negative work or negative heat. Next, the heat. Heat is the form of energy which is capable of transfer across the boundary due to difference in temperature between system and its surroundings. ಯಾವುದೇ ಎರಡು ಆಬ್ಜೆಕ್ಟ್ ಅಲ್ಲಿ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ ಈ ಟೆಂಪ್ರೇಚರ್ ಡಿಫರೆನ್ಸ್ ಇದ್ದಾಗ ಏನು ಈ ಹೀಟ್ ಒಂದು ಸಿಸ್ಟಮ್ ಇಂದ ಬೌಂಡ್ರಿ ಇರ್ಬೋದು, ಸಿಸ್ಟಮ್ ಇಂದ ಸರೌಂಡಿಂದ ಸಿಸ್ಟಮ್ ಇರ್ಬೋದು, ಇದು ಕ್ರಾಸ್ ಬೌಂಡ್ರಿನ ಕ್ರಾಸ್ ಮಾಡುತ್ತೆ. So heat is the form of energy transferred between the two substances at different temperature. The direction of energy from higher temperature substance to the lower temperature substance. ಯಾವಾಗಲೂ ಹೀಟು ಹೈಯರ್ ಟೆಂಪ್ರೇಚರಿಂದ ಲೋಯರ್ ಟೆಂಪ್ರೇಚರ್ ಕಡೆ flow ಆಗುತ್ತೆ. Because any substance or any liquids, anything, it flows higher density to lower density. ಹೆಚ್ಚಿಗೆ ಎಲ್ಲಿರುತ್ತೆ ಅಲ್ಲಿಂದ ಲೋವರ್ ಡೆನ್ಸಿಟಿಗೆ ಅದು ಮೂವ್ ಆಗುತ್ತೆ. Heat is measured in units of energy, usually calories or joules. So heat ಅಲ್ಲಿ ಯಾವಾಗಲೂ ಕ್ಯಾಲೋರಿ ಅಥವಾ ಜೌಲ್ನಲ್ಲಿ ಅಳೆಯುತ್ತಾರೆ ಅಥವಾ ಮೆಜರ್ ಮಾಡ್ತಾರೆ. ಇಟ್ ಈಸ್ ಎನ್ ಎಕ್ಸ್ಟೆನ್ಸಿವ್ ಪ್ರಾಪರ್ಟಿ and a path function. Heat exists only in transient energy. Heat supplied to a system ponders below, that is delta Q is equal to delta E plus W. ಯಾವಾಗಲೂ ಈ ಹೀಟ್ ಬೌಂಡರ್ನ ಕ್ರಾಸ್ ಮಾಡೋದ್ರಿಂದ ಇದು ಟ್ರಾನ್ಸಿಟ್ ಎನರ್ಜಿ ಆಗುತ್ತೆ. ಸೊ ಯಾವಾಗಲೂ ಹೀಟ್ ಸಪ್ಲೈಡ್ is equal to change in the internal energy plus work done. Next, specific heat. Heat ಅಂದರೆ ಒಂದು total quantity of mass and the total heat rise ಆಗೋದಕ್ಕೆ ನಾವು ಹೀಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅದನ್ನೇ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಂದರೆ ಒಂದು ಯೂನಿಟ್ ಮಾಸ್ ಸಬ್ಸ್ಟೆನ್ಸ್ 1 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಹೆಚ್ಚಾಗೋಕ್ಕೆ ಬೇಕಾದಂಥ ಹೀಟ್ಗೆ ನಾವು ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ದ ಡೆಫಿನಿಷನ್ ಆಫ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಈಸ್ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟ್ ಈಸ್ ಡಿಫೈನ್ಡ್ ಆಸ್ ದಿ amount of heat required to raise the temperature of unit mass of substance through unit degree centigrade. So the unit of specific heat is kilojoules per kg degree Kelvin. So heat required is equal to mCVT to minus T1 kilojoules, where m is mass of the substance, C is specific heat of the substance, and T2 minus T1 is change in temperature of the substance. As solids and liquids do not change its volume on heating, they have only one specific heat. The liquid ಮತ್ತು ಸಾಲಿಡ್ ಅಲ್ಲಿ ಯಾವಾಗ ಹೀಟ್ ಹೆಚ್ಚಾದಾಗ ಚೇಂಜ್ ಆದಾಗ ಅದರ ವಾಲ್ಯೂಮು ಮತ್ತು ಪ್ರೆಷರ್ ಒಂದೇ ಇರುತ್ತೆ. ಸೊ ಅದರಿಂದ ಒಂದೇ ಸ್ಪೆಸಿಫಿಕ್ ಹೀಟು. ಬಟ್ gases have two specific heats because the gas changes when heat is supplied by volume and pressure. So the specific heat of gases are specific heat at constant volume and specific heat at constant pressure. Specific heat at constant volume. Specific heat at constant volume is the amount of heat required to raise the temperature of a unit mass of gas through 1 degree Celsius when it is heated at constant volume. Specific heat at constant volume, all the heat added could be used to raise the internal energy of a system or raise the temperature system at constant volume. Hence, heat needed is less to raise the temperature of system during a constant volume process. It is an intensive property and point function. It is denoted in CV. The specific heat at constant pressure will be higher than the specific heat at constant volume. Next, specific heat at constant pressure. The specified constant pressure is the amount of heat required to raise the temperature of a unit mass of gas through 1 degree Celsius when it is heated at constant pressure. So heat specified constant volume alli heat constant irutte and specified constant pressure constant. And so in this specified constant pressure is an intensive property and Pauli function. Sum of the heat added during constant pressure will be used to do work, and hence more heat needed to raise the temperature of the system. It is denoted by Cp. So specific heat at constant pressure and specific constant volume both are same, but in a specific heat at constant volume is constant, and specific heat at constant pressure is constant, and the specific heat or heat required to raise the temperature of unit mass of gas to 1 degree in both the cases. Next topic is work. What is the meaning of work? Work ಅಂದರೆ ನಮಗೆಲ್ಲ ತಿಳಿದಿರಲಿ ವರ್ಕ್ ಅಂದರೆ ಕೆಲಸ. ಎಲ್ಲರೂ ಯಾರನ್ನು ಏನೇ ಮಾಡಿದ್ರೆ ಅದು ಒಂದು ಕೆಲಸ. So work is a form of energy which is capable of crossing the boundary due to change in state of system. So work is the product of force applied on the object and the distance moved by the object. Therefore, W is equal to m force into distance in Newton meter. For example, in IC engine work is said to be done when piston moves, and movement of piston results in change in volume of the system. So work done W is equal to product of pressure and change in volume of the piston. So W is equal to P into TV, Newton meter or joule, where W is the work done, P is applied pressure on this piston, delta V is change in volume of due to displacement of piston. Next one is enthalpy. What is the meaning of enthalpy? Enthalpy is a thermodynamic property of a working substance, and it is defined as heat supplied to the system at a constant pressure. ಯಾವುದೇ ಒಂದು ಸಬ್ಸ್ಟೆನ್ಸ್ ಮೇಲೆ ವರ್ಕ್ ಆಗಬೇಕು ಅಂದರೆ ಹೀಟ್ ಸಪ್ಲೈ ಮಾಡ್ತೀವಿ, ಆ ಸಿಸ್ಟಮಲ್ಲಿ ಕಾನ್ಸ್ಟೆಂಟ್ ಪ್ರೆಷರ್ ಮೇಂಟೈನ್ ಆಗಿರುತ್ತೆ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಎಂಥಾಲ್ಪಿ. ಇದು ಒಂದು thermodynamic property. So it is denoted by a small h. So therefore h is equal to, that is enthalpy is equal to sum of the internal energy and product of pressure and volume. Therefore h is equal to E plus PV joules, where E is internal energy and P is pressure and V is volume. Next one is entropy. Entropy is a thermodynamic property of the working substance, and it increases with the addition of heat and decreases with the removal of heat. So ಯಾವುದೇ ಒಂದು ವರ್ಕಿಂಗ್ ಸಬ್ಸ್ಟೆನ್ಸ್ ಮೇಲೆ ಟೆಂಪ್ರೇಚರ್ ಹೆಚ್ಚು ಆದಾಗ ಹೀಟ್ ಅಡಿಷನ್ ಮಾಡ್ತೀವಿ, ಟೆಂಪ್ರೇಚರ್ ಕಡಿಮೆ ಆಗೋಕ್ಕೆ ಹೀಟನ್ನು ರಿಮೂವ್ ಮಾಡೋದು. ಸೊ ಇಟ್ ಈಸ್ ಡಿನೋಟೆಡ್ ಬೈ ದ ಲೆಟರ್ ಎಸ್. So change in entropy is equal to heat added are removed. There is absolute temperature. Next, standard atmospheric conditions. The standard atmospheric condition are in two methods. First one, normal temperature and pressure, that is called as NTP, and second one, standard temperature and pressure, that is called as STP. In normal temperature is taken as 0 degrees Celsius. The normal temperature are usually taken as 0 degrees Celsius or 273 Kelvin. And normal pressure is atmospheric pressure, that is 760 millimeter of mercury or 1.01325 bar, known as normal temperature pressure. Next one is standard temperature and pressure, the STP. In STP, the standard temperature is taken as 15 degrees Celsius or 288 Kelvin. So the standard temperature is always 15 degrees Celsius. So this standard temperature 15 degrees is added to the 273 Kelvin. So we require 280 degree Kelvin. And standard pressure is taken as atmospheric pressure, that is 760 millimeter of mercury or 1.01325 bars is known as standard temperature and pressure. Here the STP and NTP, the pressure is same. In both cases the pressure is 760 millimeter of the mercury, but the normal temperature is 0 degrees Celsius or 273 degree Kelvin, and standard temperature is taken as 15 degrees Celsius or 273 plus 50, that is 288 Kelvin. Here is completed today's content, and now we discuss about multiple choice questions. In multiple choice questions, the 4 options are given, and that only one answer or option is correct. You should choose the correct answer and take the answer as a correct one. First one, energy is defined as a capacity to do the work. Here B is correct answer. Option A, heat; B, work; C, entropy; D, internal energy. The correct answer is B, so tick work. Second one, stored energy is the energy of the system available within its boundary. So option C is correct. Option A, system; B, universe; C, boundary; D, surroundings. In these options, option C, boundary, is correct. In third one, Kinetic energy is the energy possessed by the body by virtue of its motion. So option D is correct. Other options, pressure, temperature and heat, are not correct. So you choose the D option, motion. And fourth one, potential energy is the energy possessed by the body by virtue of its position. So option A is correct. Option B, C, D are both motion systems not correct. So you choose only option A. Heat is expressed in option A Kelvin, B centigrade, C joule, D watt. The heat is expressed in joules or kilojoules or Newton meter. But these four options, option C, only joule is correct. Next, unit of specific heat is option A kilojoules, option B kilojoules per kg degree Kelvin, option C kilojoules per kg, option D kilojoules per degree Kelvin. So option B is correct. So unit of specific heat is kilojoules per kg degree Kelvin. Seventh one, specific heat at constant volume is denoted by CV. So option D is correct. Next, work is a form of energy which is capable of crossing the boundary due to change in state of a system. So option A is correct. Next one, enthalpy is a thermodynamic property of a working substance and it is denoted as heat supplied to the system at constant pressure. In this option A, pressure is correct. So you choose the option A. Next one, normal pressure is atmospheric pressure, that is option A, 765 millimeter of mercury, B 760 millimeter of mercury, C 760 millimeter of mercury, D 765 centimeter of mercury. So in the question is normal pressure is atmospheric pressure is 760 mm of mercury is correct. So option C is correct answer. So thank you. Here the content, today's contents are completed. That is energy, heat, work and standard atmospheric conditions. So once again we call the contents, that is energy. Energy is defined as the form of capable of doing the work. Heat is it is one of the energy. It crosses the boundary, so it transfers higher temperature body to the lower temperature body. And work is also one form of energy. It do the some work and it cross the boundary. And last one is standard atmospheric conditions. There are two methods. One is standard temperature, pressure, and also another one is normal temperature and pressure.